It's George Tyndall, and I'm back again. It's been a couple weeks, but I'm going to explain something here because the people aren't getting it and they don't understand. And you don't understand because you don't have what I have to be able to see the things, to understand. Now, people refuse to believe that the rocks from the other planets and the other moons are already here. They are already here on Earth. Now, as far as meteorites go and everything, people that are doing meteorites have one set of rules that they go by for meteorites, and it doesn't matter where you find them at, what the environment is. And this is why all the meteorites seem to fall in California, because that's the only place they really find them, other than Antarctica and the Sahara Desert. And part of that could be because people don't know what they're looking for. Now, with that being said, first I'm going to go to NASA because they don't seem to understand their asteroid sample that they got. Now, the asteroids and the comets, they are exposed to different things in space. They travel differently. Like, take your sun grazer comet, and I'm going to explain this. And this is from your own science. Okay. If you have a sun grazer comet, okay, we'll start with a regular comet first, okay? Regular comet, millions of miles away from the sun, okay? That swings millions of miles away from the sun. Okay. Here comes a sun grazer comet. Less than 1 million miles from the sun. The excessive heat and the excessive radiation is going to convert whatever is passing the sun. Whether you want to call it nuclear fusion or whatever. Now, it says that if a comet isn't big enough, or if the comet is too big, it won't outgas. So what's going to happen is everything on the inside of that comet, or whatever it's composed of, it's going to alter. It's going to become harder. It's going to become denser. And like I said, but people don't want to they don't understand that the further away from the sun, it doesn't do anything. The closer you get to the sun, it does. It does alter things. Now, peculiar thing that I found, I'm finding all metal conglomerates, or all metal, timeout. A peculiar thing that I'm finding is all metal concretions. Okay? They're all metal. Okay? This is all solid metal. Okay? But the shell on this is thin. You can see the real thin shell on the outside. When you increase the size, you come up with a thicker shell. Now, if one of the asteroids out there that is the size of Texas, California, or the continent of North America is like this, there's going to be a thicker shell. The bigger the rock, the thicker the outside. And something that it's something that NASA doesn't even take into consideration is the density of some of these space rocks and what they're composed of. And you can't just go by taking one sample off of one asteroid and saying, well, that is like all the other asteroids. That ain't the case. And if they really wanted to listen and they really wanted to see what I had, they would understand. But it's not going to happen because they want to do things their own way, because it's all a money thing. But if what I'm finding out, if any of the asteroids out there are composed of whatever this rock right here is composed of, this heavy, it's heavy, it's a piece of metal, I cleaned it off, it's magnetic. If something weighed 100,000 times this, you're going to get more than 22 nuclear bombs. You'll probably end up with 100 nuclear bombs when it hits. But like I'm saying, people didn't look for things. They didn't understand. They don't want to listen to people. Nobody wanted to listen to people from the 1833 meteor shower. Well, all the witnesses said about that. And nobody wants to go back and research it. So I'm going to continue on with things that I've been finding. Now, we're going to go here. That picture right there, and I'm going to go to a bigger picture of it. That picture right there is a whole meteor. Not a meteorite, it's an intact meteor. It's a small one. It's one of the smaller ones that I found. This is a larger picture of it. That is fusion crust. Why does it not look like what you're used to seeing? It's because it's intact. If the whole rock is intact and it suffers less burning, that is what you get. Now, there's going to be people that are going to doubt it, but like I said, nobody out there has ever looked for this stuff before. This I happen to find submerged in clay beneath a creek bed. That's why it's well preserved, because when they land in clay, clay preserves the fusion crust on it. Now, I really don't know what to tell people. You can do it as you want it. You can sit there and listen to other people who think that they know everything when they don't factor everything in. I'm telling you, amorphous metal, metallic glass meteorites are different than regular meteorites. And if you find whole rocks, it's a bonus. But they're out there. Now, we're going to go to this picture. That's what it sort of looks like, okay? It's like a pinkish red. This is when it's wet, okay? Now we're going to go to what it looks like when it's dry. This was not made on Earth. This is amorphous metal. But the amorphous metal types that I'm finding, some of them are fuzzy. Which means, from what I'm finding, that these ones suffer virtually no damage at all. They don't even produce fusion crust. Now, what makes things really bizarre is when you come across something like this. This right here is the same rock as that picture. This is wet. The outside of this has been heated. And when it dries, it's faded. This color right here does not exist on Earth. That's almost an emerald green metal. Now, call it for what you want. You can say I'm crazy, you can say I'm stupid. this stuff is here. And if you're just teaching regular meteorite stuff and you're using that one thing and you don't factor in all this, you misdiagnose people's meteorites is what you do, because you're not factoring everything in. And some people are bringing meteorites, actual meteorites, to people, and they're telling them no, they're not meteorites because they don't contain this and they don't contain that. Now online, one expert will tell you, hey, it's got to have fusion crust. Okay, well, in the Pacific Northwest, when they land, the University of Arizona has on their websites, meteorites that are found in the Pacific Northwest don't always have fusion crust. And this is the point that I'm trying to get across. Everybody is on their own page on different things. And it's frustrating. It's frustrating because the stuff is here. But some of these colors and some of this bizarre stuff I'm coming up with, it ain't created on Earth. It's not created by Mount St. Helens. It's not created by Mount Vesuvius. It's not created by Mount Pompeii. Now, the really bizarre one that I came across is this one. Looks like a rock, okay? Looks like a rock, okay? Where's the color? Okay? Where is the color in that? Okay? You don't see it unless it's wet, because it burned on the outside. Metallic glass is different. And if these are what I think they are, they went through a nuclear fusion process, it's going to be totally different. And you won't see what you're expecting to see for a meteorite because you're going by your guidelines one way. And this is what I'm trying to explain to people. Now I'll show you. Okay? We'll show you the rock. Now we'll show you the picture that I took. The picture that I took when it was wet. This one right here is that same rock. You'll notice the different colors of green on here, the white, the different blue. This right here was not made on Earth, and it wasn't made by any mountain. It didn't come from the center of the Earth. And I don't know what people are expecting to see, but well, I do know what people are expecting to see. What people are expecting to see is what they're taught, okay? If you don't come across any of this stuff, and you don't understand, and you don't listen to what people say when they witness events, you're never going to find anything. And judging by the colors and stuff on this thing, the only planets out there that I can come up with these kind of colors is ones like Saturn, Uranus, and Neptune. And if that's the case, then we're sitting here calling planets ice giants and stuff when they have rocks on them. Now, I know for a fact they can't see the surface of all planets. So they can't say 100% sure that there's no rocks on them, or they don't have some kind of a rocky surface. Now, it's like I said, okay, things out there can be deceiving. People make mistakes. And I'm going to keep saying it. I'm going to keep saying it. Somebody made a mistake. Now they either know about it or it's all about the money thing. But I'm going to tell the people out there personally that are into meteorites and collecting them, if you don't test a rock, you don't know for sure. You don't know by looking at a picture, whether looking at the picture, unless somebody tells you something about the picture when they send it in. If they look at that picture, they cannot tell how heavy it is, whether it's magnetic, what the composition is on the inside of the rock. We're not talking about the outside, because the inside can be different than the outside. And it just really, it gets under my skin that people aren't figuring this stuff out. And the experts continue to go in the direction that they're going in. Now, as far as what I said about raw asteroids or comets getting close to the sun, if you don't think that they don't alter, then you're wrong. Because you put something in a nuclear fusion reactor, it changes. And they're trying to make them an experiment right now with them and everything, and they don't even have the kind of temperatures that the sun has. Now, I don't know how much more clear I can be about this. But eventually, like I said, eventually there will be one smart person out there that will be able to see and understand what I'm talking about. And they will see in the pictures that I'm showing. And the reason why I tell people to get their rocks checked, tested, is because I don't feel comfortable telling somebody that they don't have a meteorite if they actually have one. That is the stupidest thing that people do out there. They'll sit there and they'll have these conversations, and I watched them. And I watched one set, and I'm not going to name who it was. They had a whole bunch of people on there. They misidentified a couple meteorites. Two of them, in fact, from the stuff that I've been finding, I know were meteorites. If a rock is heated differently, if it's heated at extreme temperatures and pressures, it's not going to look the same as 3,000 degree temperature. If a rock has been exposed anywhere from 10,000 to 50,000 Kelvin or more, it's not going to look the same as 3,000 degree trip to the mesosphere. And this is just common sense. But like I said, and some of this stuff is interesting and it's fascinating. And it really is. And as far as it concerns me, you guys and your little chunks and pieces, this right here is far more prettier and sophisticated than the little chunks that you're selling everybody. $1 million for a little chunk of rock. But you know what? It isn't going to hurt me when it comes out. It's going to hurt the people out there who are deceiving people. And if you don't have everything, if you're just going with the partial thing, you don't have everything about meteorites, just what you've seen and what you know and what you haven't looked for, you don't have, you're deceiving people. And I'm going to tell people that right now. And I've left it up there. I put my offer up there. I will take anybody on national television with my stuff, and we'll have experts come in from other countries like the UK and Canada. I will take anybody on with any samples that I have. I know what I'm talking about. I know what I have found. And another thing, 250 million or 250,000 meteorites were in the sky, and not a one witness reported any explosions. But in 2013, we had one meteor come through, and it exploded over Russia, and all the damage and the noise it made. But there's no noises like that documented in an 1833 meteor shower. So I find that hard to believe that none of them exploded at all. Which means there's a reason why. And that takes me back to my hot metal shower. If these rocks were converted to hot metal and all they did was bake, and they came out like they came out of a furnace they were being cooked in, they're not going to blow up. They'll make a quenching noise because of all the cold air and the moisture that's in the air. And that's what people heard. They heard whish, whish. That's a quenching noise. That's not boom. Now, if somebody really wants to get out there and research and go back and look at what they said they even saw ones as big as Jupiter. That is huge. But, like I said, people don't want to listen to them. They just want to assume that, oh, a meteor shower is a meteor shower. And it's no different than you're saying a rock is a rock. And anybody on there, you can tell me this. This is my last piece right here that I'm going to say. Is if a meteorite is composed of tungsten, and we'll say if, you're going to tell me that when it makes a trip through the mesosphere at 3,000 degrees with a 6,000 some odd degree melting point, that's going to melt. And this is the point that I'm trying to get across to people. Different rocks are composed differently. Some of them could have really super high melting points, depending upon what they are exposed to. That's why I would really personally, I would like to drill into the center of the Hoba meteorite to see what is actually there. Why 66 tons made it all the way to the ground and didn't leave a crater. Okay, people don't get it. Smaller meteorites can leave a crater, but a 66-ton one cannot leave a crater. It's stupidity thinking on a lot of people's parts out there. And I'm really surprised that somebody hasn't managed to put a lot of this together. It doesn't add up. And I'm going to call it good.